Hello and welcome. This is John Bloom of Bloom Consulting. And today we're going to do an intro to SQL Server and how to get around in the Management Studio and learn a little bit about the basic select statement. So what you want to do is to get an instance of SQL Server, and this is one on my local machine. And what we do is we have a server type. In this case, it's the database. We also have analysis services, which is the OLAP. We have reporting services, which is the SSRS, and we have the integration services, which is the IS. So we'll go ahead and select our database engine. In this case, I have a database already loaded. There's some in there, and then so that's good. And then also you want to authenticate to the database. One way is through your NT credentials, which is on your domain. Another option is to use your SQL Server authentication, which is like your SA account, which is the global password, or if you have another account that's used to generate jobs, perhaps. So in this case, we'll go ahead and select on Windows authentication, and it accepted the credentials and it loaded the database. I remember starting back with another product back in the mid-90s, and it basically gave you this almost like a DOS prompt editor to connect to the database, and you had to type everything by hand, and the data spewed in across the screen. If you remember the DOS days where it just paged, and it was very difficult to actually see your database and work with your database. And then when this SQL Server came along, I was real thrilled to see that it had a built-in IDE to create objects and look at your data in real time in this nice format. So this is a nice feature about the SQL Server product, and it's grown over time with the 2000, 2005, 2008, 12, 14, and I believe they're on 16 now. As you can see in the IDE, we have databases. And the ones that we're going to talk about today perhaps are the AdventureWorks, which is like a default play database for the SQL Server community. We also have other objects like security, server objects, replication, management, as well as our SQL Server agent to schedule jobs. So that gives you a basic rundown of the layout. In this case, if you were to open up the database, you'll see that we have diagrams which you can create to show the relationship between tables. And a table is essentially a container for a series of data, and it's comprised of fields. So for example, we have a dim account. A dim account is comprised of columns. Those columns are listed here. You can easily change the name by doing this. Or you can view the data. For example, you can just right click, say select top 1,000 rows, and what it'll do, it's making a call to the database by a language known as SQL, Structured Query Language. And that Structured Query Language is going to present itself here. It actually writes the code for you because I selected the top 1,000. And the fields that are here line up accordingly with the fields here because they're specified here. So perhaps I say, well, I don't want to view these fields, so let's just view these. You press F5, and there you go, and then we have less fields. So the way it works is that the database contains a series of data in a table, and those tables are comprised of fields, and these fields have types. For example, how old are you? Well, I'm 22, so that's a number. A number is an int. There's no decimal. So if we had a decimal field, we could choose a float or a decimal. We also have strings. What's your name? John Bloom. John Bloom is a string. It's not a number. So we can have a varchar. A varchar indicates that it's flexible. So in this particular field, I could write up to 300 characters. I could also put in 1 character because it's expandable. Now, if I had a car field, I don't see any in this particular table, but a car field, for example, if you specify 300 digits, like here, N car 3, it'll store off 3 units, 3 characters for every field in the database, because that's the way it works. A car is a finite number, and an N varchar, or a varchar perhaps, is flexible, as long as you don't exceed. Now the N indicates another type, so it'll handle international stuff. So you also specified the field length, and then this thing here called null, that means like empty or nothing. So let's say I had an address table, and address 2, there wasn't anything in there. You could store it as a blank. So it's actually it's a piece of data which is blank, or you can actually insert a null, which is nothing. So if you don't insert anything, it's null, and you can specify null or not null. And if you specify not null, well, that means you have to produce a value. And if I try to insert a record into that table that has not null, it's going to produce an error. So you have to trap it upstream, perhaps in your web application. Another thing to notice about these SQL Server tables, like many other SQL tables, is that we have a primary key. A primary key is a unique key in that the values cannot duplicate. In this case, it's an integer, so it's a 1, 2, 3, 4, 5, and the numbers will never duplicate, and you can identify the row uniquely through this key. So if I was to click Modify, for example, this screen comes up, which allows you to modify the table. Now, if we were to scroll down here, it's known as an identity. And identity means it's used for primary keys. Is identity equals yes? You could also select no. And this nice drop down, like I said, in the pre-days of database world, we didn't have these nice luxuries of click, click, click. And that's one of the features I like about working in the data space is there's very little code written, actually. It's all done for you with these nice wizards, perhaps. Not completely, but it's a lot easier than writing code from scratch. This identity increment 1, and seed means where do you want to start. So I could seed that at 50,000, 150,000, whatever, and it'll start there, and then it'll increment based on 1 unit, and that's how it works. So that's the primary key, is an identity key, so that's how it works. So that's good. So that's nice that we have this data and all, but who cares? So why would you care about having data? Well, just about every company stores off data because they have these things called applications that do stuff. And with that application, it'll save the data. And from the data, you can have somebody like a report writer or a SQL developer. And what they'll do is they'll play with this data all day. They get paid for it. And then basically, they can write queries. And these queries perhaps are in reports or dashboards. And somebody reads these reports and makes some decisions, perhaps. It says, oh, salesman X is doing real well. Salesman Y is not doing so well. How much commission should we give him? Well, how many units did he sell this month? What was the dollar amount associated? Let's give X a nice bonus, and let's give Y the option to find another job somewhere else. So that's how it works. When you're working with data, we typically have a 4-part naming convention, and well, so typically in a SQL statement, we have a select something from something, and the from is the 4-part naming convention. So you have the database name, which you see here. That's called the database name. And then this is a schema. So within the database, we have a schema. DBO, you can name it whatever. You can say green, you can say frog, whatever you want to call it, that's the schema. But typically we use meaningful names. Now the default is a DBO. And then you can assign specific rights to the schema, to users, for access level. And then also the table name. So database, schema, table name. Now, what you don't see there is that it's actually localhost in this case because it doesn't recognize it. So the way that you have to get around it is actually we're not in localhost. We're in my bad. We're in Bloom laptop. So what you would do is you could put Bloom laptop dot, and guess what? There it is. So that's your server, your database, your schema. Now, once you write code for a living, it's typically you clean it up and make it nice so the next person after you doesn't swear at you when you leave. So that's what happens. And then, okay, so from is the table, and the table resides here, and the table is within a database, which is in a server. Now, if you had a link server, perhaps you could join tables from different servers as long as you set the configuration that each database can see each other and you have your appropriate rights. But anyway, what do we do with these tables? Well, this table is dim currency. Now, currency is money, and money exists in all these different places, and they have specific information. So in this case, we're selecting the top 1,000. And these are the 3 fields that we're selecting. But I'm kind of lazy. I'm not really. But anyway, you select star. Star is like a keyword. Everybody knows select star. And it's evil. You're not supposed to do it. But for the demo purposes, we'll select star. So we select star. And guess what? it brought in the select top 1,000, meaning pick off the top 1,000 from the table and give me all the values from this table. Well, I guess that's right. Yeah, because currency only has the 3 values. So that's why there's only 3. So there you go. And if we were to take off the top 1,000, there's 105 rows. So that's nice. And you say, well, that's nice. But I only want to look at the Australian dollar because I'm curious to know what that is. So if you wanted to limit your select query data set, return result set, there's a keyword called where. So select from where, and then you say, well, this field apparently looks like the currency alternative name. So we'll say currency alternate key equals, and then what we do is we put a single quote, not a double quote, in AUD. So I would like only this row to be selected. So I put in my where clause from this table, and I select all the fields. Go ahead and F5 for execute, and there it is. So it returns result set. So that's pretty cool. So now I can pick off a specific record. In the SQL languages, so that you can manipulate these queries to return the desired result sets, and that's nice. Now, moving on, we also have these things called fact tables. In the data warehouse schema, you have a dim table and a fact table. In this case, the fact table contains a series of measures, and a measure is simply a dollar amount or account or currency or what have you. Usually numbers, date keys, and such. So scanning over this table, like I said, you have your freight, which is a unit, dollar amount, sales amount. Now the thing is, I was looking for something that we could join on. Now when I say join, I would like to join the data content from the fact table to one of the dim tables, so that what you're doing is you're consolidating tables so that all the fields are available from both tables, and the way you do that is through a join. What's a join? A join is a statement to unite two things. In this case, I see that we have a order date key, which is nice. And if I expand this date table, for example, guess what? There's a date key. So what I'd like to do is join the two tables. So what I do first is I drag this over here to specify. I'd like to do an inner join. There are several types of joins. One is called an inner join, and one is called a left outer join. I would say that's 90% of the code that I write. There's also cross join and right join, and there's a whole bunch of others, but I predominantly use the inner join and the left join. And what it means is an inner join will return a result set where the keys that you're joining on match one for one. So for example, if I had a customer table, and the customer table had addresses, and the addresses, we don't want to store it off the address in every table, so we create a customer table and an address table, and we join the two. And for example, if I wanted to bring in customers that resided in Florida, well then if the customer table had key with Florida and the address table had a key with Florida, well, it would return the result set. But let's say that I had a customer from Puerto Rico, but I didn't have a unit entry in the address table for Puerto Rico. Well, it will not find an equal match because the key doesn't exist Puerto Rico in both tables, so it would not return that result set. But if I did a left outer join, it would, because it brings in not equals. So I don't know if I explained that correctly, but anyway, that's how it works sort of. So in this case, we have table 1 and we have table 2. What we can do is create these aliases, and then an alias basically is a way to reference the object without specifying the full name. It's abbreviated. So what we'll do is we'll say d.date key equals fis.date key, and we'll go ahead and check it using this checkbox. By golly, it worked. So then we click the execute button and it says error. Alright, so in this case, I screwed up. And by meaning I screwed up, if you look closely here, we're in the wrong database. We actually want to be here. So one way I could do is just click execute. The other way I could do is stay in the master database and just prefix it with our three-part naming convention like so, and then we'll be good to go. So that's why it didn't recognize the field name. So now it should, and guess what? It accepted the join. Well, guess what else? I can go ahead and remove, I can just say select star from everything. And what that'll do, it'll join the two tables and it'll return the result set for both tables. I say, well, that's fine, but I only want to look at the fact table data. Well, guess what? You can see that it stops here at the customer PO name, and you say, well, I like to bring in the date stuff first. So guess what? Now the date table shows up first, and then secondly, the fact table shows up. You say, well, this is known as a comment. It's a dash dash, and then it makes it green, and then also we'll just clean it up. And now what it'll do, it'll just return the date stuff. So that's nice. So typically, that's the way you do joins in a SQL Server database, no matter what the version is. You have a table, you have another table, and you provide the join on, and then usually the keys are matched between the two tables, and they're the same type. Like you cannot join a varchar to an int. You can, but you'd have to convert it, and hopefully the data aligns properly. And secondly, it's going to slow down your query because it has to perform that extra calculation. So that's basically how it works. So that's pretty cool. And we basically talked about the SQL Server and how to connect, and then the structure and the database and the four-part naming convention and the basic select statement. And then we showed the join and how that works and everything. So that's basically how it works in SJ's intro to SQL Server select statement. And again, this is John Bloom of Bloom Consulting. I hope you enjoyed the demo and stay tuned for more videos in the future. Thanks for watching.